Grade 12s, I'd like to use this opportunity to just demonstrate using a model of a hydrocarbon, isomerism. So I've already made a lesson presentation, so I want to go and look at the isomers of butane. Now butane has 4 carbon atoms, 1, 2, 3, 4. And it's got 10 hydrogen atoms. So C4H10 is the general formula or the molecular formula for butane. You can see when I turn the molecule like that, the first carbon's got 3 hydrogens to it, the second carbon's got 2, the third carbon's got 2, and the fourth carbon's got 3 hydrogens joined to it. So the condensed structural formula would be CH3, CH2, CH2, and CH3. But there are possibilities where the 4 atoms are not arranged in a straight chain like this. So I'm going to build an isomer, a chain isomer of butane. You see, what we could have is a situation where there are 3 atoms in a chain and the 4th carbon atom joins onto the chain as a side chain. So now, excuse me, now that atom forms a functional group or a side chain attached to the longest carbon chain. Now it doesn't matter how I look at this molecule. I can turn it in different directions, look at it from different angles. Doesn't matter what it will look like. It still has 4 carbons and 10 hydrogens to it. This carbon has 3 hydrogens, this carbon has 3 hydrogens, that carbon's got 1 hydrogen, and this carbon's got 3 hydrogens. So the molecular formula is still C4H10, but the arrangement of the atoms are different. And because of that, this molecule will have different physical properties to that molecule there. This was a straight chain molecule, and this straight chain molecule, which is non-polar, as I explained in the previous video lesson, it's non-polar, it will have London forces between it. Now the molecule is more made shorter and rounder, and the place for contact between other molecules of this type and this one would be less. So the London forces between the non-polar molecules will be weaker, means this molecule will have a lower boiling point. So if I draw out the structural formula for this molecule, I'll have a CH3. Sorry, let me draw the structural formula out. I'll have a C with its 3 H's joined to another carbon with 1 hydrogen, and that carbon is joined to another carbon with 3 hydrogens. This carbon is joined to a carbon with 3 hydrogens. Now we can't call this molecule butane anymore. We have to distinguish between this molecule, the CH3, CH2, CH2, CH3 molecule, and this molecule, the CH3, CH in brackets CH3, that indicates the this side chain, and CH3. Now these are the rules we take. We number the carbon atoms in the longest chain, the longest continuous chain. So that I would start as my first carbon, that's the second carbon, and that's the third carbon. I don't have to take it that way. I can count another way. I can say that's the first carbon, that's the second carbon, and this is the third carbon. I can even count in another way, start at another point to count. 1, 2, 3. It doesn't matter how I count the continuous longest carbon chain in this molecule, it will have 3 carbons. And this group of atoms here is joined to the second carbon. Now, in order to name this compound, we need to use the IUPAC, International Union of Pure and Applied Chemistry rules. The longest chain determines the base name. So the carbon, the alkane with 3 carbons in the chain, is called propane. So that comes from the 3 carbons in the chain. And this side chain that we have here has 1 carbon in it. Now, the organic compound with 1 carbon in it usually has 4 hydrogens. And that would be called methane. But now this methane has lost a hydrogen in order to link up to that carbon. So this methane becomes methyl when it turns into a side chain. So methane becomes methyl, just choose the right color pen. So this is methyl propane. And although this methyl group can't join onto the first carbon, then it will turn back into butane, or onto the third carbon, it will also turn back into butane. It is good practice to say on which carbon in the long chain has this methyl joined, and it's the second carbon in the long chain that the methyl joint. Well, the rule says we need to put dashes between a number and a letter. So it's 2-methyl propane. This is the only isomer of butane. The longer the chain becomes, the more possible isomers there will be. So the next one is I'm going to discuss the isomers of pentane. Now, because the length of the chain changed here, this is a chain isomer. Of butane. Good. Let's clear this board and go to pentane. So here I have a model of a molecule of pentane. pent because there are 5 carbons in the longest chain, longest continuous chain. 1, 2, 3, 4, 5. And the number of hydrogens would be 3 and 2 is 5, and 2 is 7, and 2 is 9, and 3 is 12. So this is the structural formula for pentane. If I want to draw it out, it's C with 3 hydrogens, C with 2 hydrogens, another C with 2 hydrogens, another C with 2 hydrogens, and a C with 3 hydrogens. Now the aim of this game is to look at the different chain isomers, or I'll introduce another type of isomer to you soon. Okay, so if I take one of these carbons and I add it as a side chain, what will happen? Let's see what will happen. I'll create a chain with 4 carbons in the continuous chain, and then this would be our methyl group. This would be the methyl group that attaches somewhere to the longest chain. So it can't attach itself to the first or the last carbon in the chain, because then it will be the straight chain pentane. But it can attach itself to this atom of carbon or that atom of carbon. Now I want to show you something, that if I look at the molecule from this side, it doesn't matter. The methyl group is attached to the second carbon in the chain. If I take it 1, 2, 3, 4, so the basic structure of this molecule is a butane, and there's a methyl on the second carbon. You can't count the carbon chain from this side, 1, 2, 3, and say 3 methyl butane, because the side chain or the functional group must be on the lowest possible numbered carbon. So it's got to be close to the end. You count the longest continuous chain so that the methyl group or the functional group will be closest to the end of the molecule in this case. So this then is CH3, CH, but there's another C with its 3 H's, CH2, CH3, the structural formula for the molecule. You can see the molecule is shorter than the straight chain molecule, so its intermolecular forces will change to be weaker, because the properties of this molecule differs to the properties of that molecule in some ways, like the boiling point. We need to distinguish between the two molecules. So we will first of all number the longest chain of carbons, 1, 2, 3, 4, and then give the carbon molecule, the hydrocarbon, its basic name. It is a butane. And on the second group of carbon, there is a methyl group. So this is 2-methyl butane. Can't we make the chain shorter? Can't we take another atom and from the longest chain and add it somewhere else, and still have C5H12. Let's see. I'm busy doing the wiggling stuff here. I've lost nothing, no atoms, thrown no atoms away, but now the molecule is even rounder. It's still got the general formula C5H12, it's lost no atoms, but this molecule has a shorter chain than the 2-methylbutane, so its physical properties will be different. If the physical properties are different, we need to be able to distinguish between the different types of isomers. So let's do that. I need to take some things away here. So what I have done is I took a carbon out from this chain, and we made the chain even shorter. Sorry, I want to write this one down there. So the previous one was 2-methylbutane. Now this one has another carbon joint there. So this one, you see, has 1, 2, 3 carbons in the longest chain, or we can say 1, 2, 3 carbons in the longest chain. We can number these carbon atoms from any place. 1, 2, 3, or 1, 2, 3, or 1, 2, 3. Doesn't matter how we count these carbons, there will only be 3 consecutive carbons in a row. Let's stay to convention. 1, 2, 3. Carbon 1, carbon 2, carbon 3. So the basic name of this isomer is based on the alkane with 3 carbons. So this is propane. Okay, there is a methyl group joined to the second carbon. So that is a methyl group there. This one is my methyl, that one. And there's another methyl group joined also to the second carbon. There it is. Now if there are 2 methyls, the methyl changes to dimethyl. So it's dimethyl propane. And although there isn't another position but the second carbon where these 2 methyls can join, there are molecules with longer chains where these methyl groups can join to different carbons. So let's follow the convention and let's stick to giving the number to which one of these methyls are joined and the second one. So both the methyls are joined to the second carbon in the propane chain. I think this is enough for you to handle right now. In the next video, we'll look at the isomers of hexane. Thank you. Bye for now.